Today we will be discussing Chapter 3, Section 3, which is found on page 73 of your book. It is titled Hydrosphere and Biosphere. When you finish this section, you should be able to name the three major processes in the water cycle, describe the properties of ocean water, describe the two types of ocean currents, explain how the ocean regulates Earth's temperature, discuss the factors that confine life to the biosphere, and explain the difference between open and closed systems. I want you to think about and estimate the percentage of the Earth's water that is salt water and the percentage that is fresh water. From previous science courses, you should have learned that about 97% of the Earth's water is salt water, and the remaining 3% is fresh water. In your journal, I want you to design a graphic to represent these percentages. The hydrosphere includes all the water on or near the Earth's surface. This includes water in the oceans, lakes, rivers, wetlands, polar ice caps, soil, rock layers beneath the Earth's surface, and clouds. The water cycle, also called the hydrologic cycle, is the continuous movement of water from the ocean to the atmosphere, to the land, and back to the ocean. Draw this picture of the water cycle in your journal. Evaporation is the change of a substance from a liquid to a gas. The majority of water continually evaporates from the oceans. Water also evaporates from lakes, streams, and the soil. Water is also released from leaves of plants in a process called transpiration. Condensation is the change of state from gas to a liquid. Water vapor forms water droplets on dust particles, forming clouds. In the clouds, the droplets collide to create larger, heavier drops that fall from the clouds as rain. Precipitation is any form of water that falls to Earth's surface from the clouds. That includes rain, snow, sleet, and hail. All of the oceans are joined in a single large interconnected body of water called the world ocean. The world ocean plays an important role in the regulation of the planet's environment. The largest ocean on Earth is the Pacific Ocean, with a surface area of about 155,557,000 square kilometers. The deepest point on the ocean floor, the Challenger Deep, is found in the Pacific Ocean. The Challenger Deep is located east of the Philippine Islands at the bottom of the Mariana Trench and is about 6,900 miles below sea level, which is deeper than Mount Everest is tall. Oceanographers often divide the Pacific Ocean into the North Pacific and the South Pacific based on the direction of the surface current flow in each half of the Pacific Ocean. Surface currents in the Pacific move in a clockwise direction north of the equator. Surface currents in the Pacific move in a counterclockwise direction south of the equator. The second largest ocean on Earth is the Atlantic Ocean and covers about half the area of the Pacific Ocean, which is a surface area of about 76,630,000 square kilometers. Like the Pacific Ocean, the Atlantic Ocean can be divided into north and south halves based on the direction of surface current flow north and south of the equator. The Indian Ocean is the third largest ocean on Earth with a surface area of 73,762,000 square kilometers. The smallest ocean is the Arctic Ocean, which covers 14,560,000 square kilometers. The Arctic Ocean is unique because much of its surface is covered by floating ice called pack ice, which forms when either waves or winds drive together frozen seawater, known as sea ice, into a large mass. The difference between ocean water and fresh water is that ocean water contains more salts. Salinity is a measure of the amount of dissolved salts in a given amount of liquid. The water cycle affects ocean salinity. Salinity is lower in places that get a lot of rain or in places where fresh water flows into the sea. In contrast, salinity is higher where water evaporates rapidly or water freezes, leaving the salts behind. Most of the salt in the ocean is sodium chloride, which is made up of the elements sodium and chlorine. Although you can see, many other elements can be found in the ocean as well. The surface of the ocean is warmed by the sun, while the depths of the ocean, where sunlight never reaches, are very cold, just above freezing. Surface waters are stirred up by waves and currents, so the warm surface zone may be as much as 350 meters deep. Below the surface zone is the thermocline, which is a layer about 300 to 700 meters deep, where the temperature falls rapidly. One of the most important functions of the world ocean is to absorb and store energy from sunlight, which in turn regulates temperatures in Earth's atmosphere. Because the ocean both absorbs and releases heat slower than land, the temperature of the atmosphere changes more slowly. If the ocean did not regulate atmospheric and surface temperatures, temperatures would be too extreme for life to exist on Earth. Local temperatures in different areas of the planet are also regulated by the world ocean. For example, the arrow is pointing to the British Islands, which are warmed by the waters of the Gulf Stream. Currents circulate warm water, causing land areas they flow past to have more moderate climates. Stream-like movements of water that occur at or near the surface of the ocean are called surface currents. Surface currents are wind-driven and result from global wind patterns. Surface currents can be warm or cold water currents. However, currents of warm water and currents of cold water do not readily mix with one another. Deep currents are stream-like movements of water that flow very slowly along the ocean floor. Deep currents form when the cold, dense water from the poles sink below warmer, less dense ocean water and flows towards the equator. The densest and coldest ocean water is located off the coast of Antarctica and flows very slowly northward, producing a deep current called the Antarctic bottom water. Fresh water is water that contains insignificant amounts of salt. Most of the fresh water is locked up in ice caps and glaciers. The rest of our fresh water is found in places like lakes, rivers, wetlands, the soil, and atmosphere. A river system like the Mississippi River system shown in the slide is a network of streams that drains an area of land. It contains all of the land drained by the river, including the main river and all its smaller streams, which are known as tributaries. Rain and melting snow will either sink into the ground or run off the land. Most of this water trickles down through the ground and collects under the Earth's surface as groundwater. The porous rock layer that stores and allows the flow of groundwater is called an aquifer. Although groundwater makes up only 1% of all the water on Earth, groundwater provides fresh drinking water and supplies farmers and industries with their water needs. The biosphere is the part of the Earth where life exists. It extends from about 12 kilometers below the surface of the ocean to about 9 kilometers into the atmosphere. It includes both the biotic and abiotic factors of the Earth that allows life to exist. The materials that organisms require to survive must be continually recycled. Suitable combinations of the materials that organisms need are found only in the biosphere. The reason the biosphere is located near the Earth's surface is due to sunlight. Plants use sunlight to produce food, and almost every other organism gets its food from plants. The energy used by organisms must be obtained in the biosphere and must be constantly supplied for life to continue. When an organism dies, its body is broken down and the nutrients in it become available for use by other organisms. This flow of energy allows life on Earth to continue to exist. Closed systems are systems that cannot exchange matter or energy with its surroundings. They don't exist in pure form in nature. In the example of the fishbowl, light enters and heats up the water. This heat is then radiated back out of the fishbowl, representing an exchange of energy. None of the matter, water, plants, stones, fish, leave the bowl though, and no extra matter enters. This picture is an example of an open system. Open systems are systems that can exchange both matter and energy with its surroundings. Most systems in nature are open, from ponds to ecosystems to biomes. Energy is transferred in the same way. Light enters, it's absorbed, and heat is emitted. Matter is transferred when birds enter this system, when the ocean currents bring and take away water, when the wind blows, and when fish swim into the ecosystem. Today, Earth is essentially a closed system with respect to matter, but an open system for energy, as energy travels from the sun to plants to an animal, which is eaten by another animal. In the process, some energy is lost as heat to the environment and returns to space.